Hello, I'm Doro Faitelson, and I'm going to present our paper, How Developers Choose Names. This is a journal first paper from IEEE Transactions in Software Engineering. The presentation will have three parts. I'll first describe an experiment when giving names in a certain scenario. Then I'll talk about a model we devised based on analyzing the names from the experiment. And then at the end, I'll describe a second experiment where we use the model and try to elicit better names. So let's start with the first experiment. This experiment reflects two research questions. One, what is the probability that two developers would give the same name in the same situation? And two, what is the probability that developers would understand names given by others? In this presentation, I'll focus only on the first question. The procedure we followed is to create 11 programming scenarios and then ask about naming variables, data structures, and functions in these scenarios. We then normalize the names and analyze the results. Here's an example scenario. I won't read it all to you, but essentially this describes a credit card company where users of the credit card can accumulate benefit points by using the card. Specifically, they get 1 point for each 2,000 shekels that they charge on the credit card, up to a limit of 4 benefits per month. Given this scenario, we asked the experiment participants to give 3 names. First, name the constant holding the value 4, then name the constant holding the value 2000, and finally name the variable holding the number of benefits the client is entitled to during the current month. The experiment was executed on the Qualtrics online platform in 2 phases, first with professional developers and then with students. Each participant was presented with 6 randomly chosen scenarios out of the 11 because we found out that 11 scenarios was too long. A total of 234 people answered at least one question, of which 75% were male. The average experience in programming was just under 6 years, and 70% were students. So one of the results we got concerns the length of the names, and we found that experienced developers, defined to be those with at least 5 years of professional experience, gave names which were longer than inexperienced students with at most 2 years of experience. The difference was 1.75 characters longer on average and 1.26 words longer on average, given that many names include more than 1 word. But it's more interesting to look at the names themselves. So obviously we got many names for each question. These are example names we got for the constant 4 in the scenario I showed you before. And initially it looks like these are very different names. It's hard to see any consistencies. But if you rearrange them, you can see various emerging patterns. So let me walk you through these patterns. One of the patterns is that the certain names are repeated multiple times. And in order to quantify the distribution of name usage, we define 2 metrics. The first metric is the focus. Focus is defined to be the number of times that the most popular names appeared, divided by the total number of names we received. The second metric is diversity. Diversity is the total number of different names we received, divided by the total number of all names. These graphs show the results for all of the questions in our scenarios. What we see here are CDFs, cumulative distribution functions of the focus and the diversity in the different questions. Specifically, we see that in 80% of the questions, the most popular name was used in only 5 to 20% of the responses. So this focus is rather low. At the same time, in 50% of the questions, the number of different names received was more than 75% of the responses. So diversity tends to be high. Additional patterns concern repeated concept words. For example, the concept of benefit points in the scenario I described could be expressed either by the word benefits or gifts or rewards or points or treats, etc. Likewise, the concept of renewing the account for each month was expressed either by per month or by monthly. And the fact that there's a limit on the number of points you can accumulate was expressed usually by the word max, but sometimes by the word limit. Other patterns we see are certain molds for the names. For example, there's a mold max x per month, where x could be any of the concept words I showed before. There's another mold that's max x per month without the max x without the per month part. Finally, another pattern we see is that different participants use the same words within a different order. For example, one participant suggested the name benefit max num, while another suggested max benefit num. If we summarize all of these observations, we see a repeated use of certain molds. We see that certain different molds may contain the same concept, and we see a repeated use of certain concept words, independent of what the molds they are in. We also see a different order of the words. And then we started thinking what process could lead to these observations. And we decided to create a model of how names are invented that could explain these observations. Our model is as follows. We suggest that maybe developers invent name in 3 steps. First, they decide what concepts to embed in the name. These concepts represent the problem dimensions. They then choose which words to use to represent each of the concepts. These are the concepts words I gave in the example. Finally, they decide on the order of the words and the structure of the name. This corresponds to the molds. Now, we do not necessarily claim that this model is explicitly followed by programmers, and they actually think in these 3 steps in a serial process. However, we do claim that the model can be useful in understanding naming. For example, we think that the model can be used to explain the large diversity in names. And we suggest that maybe the large diversity in variable names is a result of multiplying the options in all of these 3 steps. In the first step, developers have alternative options for which concepts they decide to put in the name that are relevant for this variable. Then they have many options for which words to use to represent each concept, and they have different options for the order of putting those words together. So multiplying all of these options together results in a low probability that 2 developers will eventually select the same name. In our experiment, the median for selecting the same name was 6.9%. And if we look at all of the results, we find that in 8% of the questions, the probability of, the estimated probability of selecting the same name was less than 15%. So as I said, we do not claim that the model is actually used explicitly by developers. We don't really think they think this way. But what if they did think this way? What effect would that have? So we created a second experiment, which reflects the following research question. 1, does knowing the model affect the names produced by developers? And 2, are the names produced with the model superior over the names produced in the original experiment? The procedure we used is exactly the same thing in the original experiment. We used the same scenarios and questions. But first, we give the participants a short tutorial about the 3-step model. We then compare the model, the names given in the 2 experiments. During execution, this experiment was performed by 100 participants with similar demographics to the first experiment. Note that in order to compare the names in the 2 experiments, we need to judge name quality. To do so, we recruited 2 external judges. Importantly, these judges do not know about the experiment. What the judges did was to independently follow the following protocol. First, they learn about each scenario. Within each scenario, they learn about the questions being asked. And for each question, they view 60 pairs of names, 1 from each experiment in random order. And they judge which name they think is better for this question in this scenario. Here are the results which we received. First, as a control, we see that the judges did not prefer the first or the second name, but prefer them equally. However, they did tend to agree about which name was better, and they did agree in 70% of the cases. Focusing on these 70%, we find that they preferred the names created with the aid of the model by a ratio of 2 to 1. These names are judged to be superior. We also find that they preferred the longer name by implication that the model helps people create longer name. Recall that this also reflects the names preferred by experts, as we saw in the original experiment. So, to conclude, we find that developers tend to choose different names in the same scenario, and that this can be explained by the 3-step model. So the developers first select the concept to include in a name, then select the word for each concept, and then create names from these words. And they have many options in each step, and multiplication is what causes the variability. We also find that using this model explicitly can be used to improve naming. Thank you.
This session, the Q&A is for a paper on how developers choose names. We have the first author of the paper, Dror Feitelson from the Hebrew University of Jerusalem, here with us to answer your questions. So please pop your questions into the chat panel so that he can answer them. Dror, thank you very much for the nice presentation and for the very nice paper. So we have 3 questions now, and I'll proceed to read the first one. did the research take a look at non-native English speakers choosing the variables names? Would that change the results?
So actually, most, if not all of our subjects were non-native English speakers, because they were local here in Israel, they are native Hebrew speakers, but they do know very good English, because both, if you're a developer, you have to know English nowadays. So they're bilingual, and we actually used that in the paper. I didn't talk about it in the presentation, but we actually used the fact that they are bilingual in order to give them the description of the scenarios in Hebrew in order to reduce the bias on the names that they will give. So actually, the fact that they are not native English speakers is a basic part of the research. And does it change, influence the results? Probably. We can see that they are not as fluent in English as native English speakers would be. So sometimes they make small mistakes in semantics of words and don't choose the optimal words. But I don't think that it's a big influence, but we should repeat it also with English speakers, and we have other methodologies to actually elicit names for English speakers without having too much bias also. So that's something we should do.
Thank you very much. We have another question by Edward Geringer. What ways can the model be used to improve names? Improving naming is a crying need in most programming.
So I think that what we showed actually gives part of the answer to this. We actually showed that if you just tell developers about this model and give them a sort of short tutorial on this model and ask them to use it, then they improve their names, at least partly. And we don't really know that this is strictly necessary. So one of the things we plan to do in the future, and we haven't done yet, is to see whether we can get similar results on improving naming using a simpler sort of incentives. Because what we did here is we actually told them about the model. We said there are 3 stages, and think about this model when you're giving names, which is sort of rather heavy, and then it's a lot of work. But maybe if we just tell them, research has shown that using longer words with more concepts leads to better names. Just that. So maybe if we just remind developers about this when they're writing code, maybe they'll also give better names. But we haven't done that experiment yet. So that's future work, and we hope to do that.
Great, yes. There's a question by Fatima Farad. What are some practical applications of your study?
So one practical implication is what I just said, that it could lead to ideas about how to elicit better names for developers. But I must admit, I'm not really, I don't really think that is necessary. We did this as sort of basic science. We're sort of more interested in the science behind software engineering, understanding what makes people behave in certain ways, and what are the ideas behind giving names. And we want to have a better understanding of this issue. So that's our main motivation. It's not really practical application, but I think that
Dror, are you still there? Okay, looks like we have lost Dror momentarily. So Fatima, perhaps I could just venture a conjecture on another application. So if you could automate somehow this model for naming, you could, for example, use it for code refactoring. So if you have code that is that developers feel like it's very unreadable or hard to understand, perhaps you could attempt to rename variable names based on this model. There is some work on this. There is some work that tries to use machine learning in order to synthesize names that are more meaningful for variables. And that's also related to Jonathan's question. There is also some work on trying to generate more meaningful method names. For example, in the context of test generation, there is some work on trying to generate more meaningful and descriptive test names. So perhaps this model could also feed into that area. Dror, are you still here with us? Okay, let's give the author a chance to join us again. Okay, it looks like we have lost the author for this paper. We still have 3 minutes left until the next presentation starts. So what I would suggest is, of course, if he joins again, he still has a couple of minutes left to answer one question, perhaps. But I will certainly make sure that he follows up with Fatima, with Jonathan, with James, so that this answer can be clarified. Just for all of you, if you've just recently started following sessions, at the end of this slot, a pop-up will appear saying if you want to go to the discussion room for this paper. No worries, George. That's fine. The connection seems to be bad. So I was saying that you just click on the join discussion room, and you will be able to connect with Dror and perhaps have a personal discussion with him for the specific paper. Okay. So thank you for attending the Q&A. Thank you, Dror. I'm sorry the connection wasn't very good, but I'm sure you will be able to catch up with the people who asked questions in your paper's discussion room. Okay. Thank you all very much, and I'll see you soon. Hi, Dror, you're back. I can see you again, but you're muted. You're muted, Dror. Time is up anyway. I'll see you in the next Q&A session.